The James Webb Space Telescope has captured something truly astonishing. Lights that seem to emanate from a distant city, shining from a point 4 light-years away. This remarkable discovery has reignited interest in the possibility of extraterrestrial life. The telescope focused its gaze on Proxima Centauri b, the closest exoplanet to our solar system, and detected mysterious bright flashes. Could these be signs of an alien civilization? Stay tuned to find out more. For a long time, scientists and curious minds alike have dreamed of discovering life beyond our planet. Any scientific hint suggesting the existence of life elsewhere has always sparked excitement. Recently, the James Webb Space Telescope delivered what many consider a groundbreaking indication of life somewhere in the cosmos. While scanning the depths of space, this powerful telescope observed something fascinating on Proxima Centauri b. It detected lights strikingly similar to those of cities, raising the tantalizing possibility that an extraterrestrial city might exist on that distant world. This revelation has generated widespread excitement and curiosity among scientists. It could be the discovery they've been hoping for, a sign that intelligent beings may exist beyond our current understanding, organizing their societies in ways we are only beginning to imagine. The idea of city-like lights located an incredible 4 light-years away has left NASA engineers in awe, wondering how long these lights might have been visible, waiting for our technology to catch up. David Kipping, an astronomer at Columbia University, described Proxima Centauri b as a particularly complex planet. Unlike most rocky planets that absorb sunlight and emit energy primarily in the form of infrared radiation, this exoplanet exhibits unique behavior due to its close and dynamic relationship with its parent star, Proxima Centauri. The James Webb Telescope's discovery highlights its extraordinary importance. Its ability to capture infrared wavelengths was instrumental in detecting the unusual thermal behavior of Proxima b, providing key insights into the planet's atmospheric conditions. Researchers plan to continue using this telescope to explore Proxima b's atmosphere in detail and investigate whether it might be habitable. Thanks to its sensitivity to infrared light, the James Webb Telescope can observe what happens on the planet during its night cycle. Detecting faint light in the vast darkness of space is notoriously difficult for most telescopes, but the James Webb can pick up even the faintest glimmers. This makes it an ideal tool for confirming whether the supposed city lights on the dark side of Proxima b are real. The telescope can detect artificial light in space if it falls within a very narrow frequency band, much narrower than the light emitted by normal stars. Proxima Centauri b has a dynamic interaction with its star. One side of the planet is tidally locked, continuously facing the star and absorbing intense energy, while the other side remains in darkness. As the planet orbits, it experiences day and night cycles somewhat similar to Earth's, with scorching heat during the day and cooler temperatures at night. The planet also undergoes significant temperature variations, influenced heavily by its composition. For example, if Proxima b lacks a substantial atmosphere, the temperature difference between its day and night sides would be extreme. Without the moderating effect of atmospheric gases or oceans, the day side would become intensely hot while the night side would plunge into freezing temperatures. These dramatic thermal variations are of great interest to astronomers because they provide clues about the planet's atmospheric makeup. The James Webb Telescope, with its unique infrared imaging capabilities, can effectively analyze Proxima b's thermal emissions, offering valuable information about the planet's atmospheric properties. Interestingly, the telescope's orbit around Earth coincides with Proxima b's orbital period, allowing detailed observations of the planet's day-night cycle every 11.2 Earth days. If Proxima b does possess an atmosphere, the next step for researchers will be to study its chemical composition to assess its potential to support life. Signs such as oxygen, water vapor, and methane would be strong indicators of habitable conditions. Detecting these elements involves analyzing the light passing through the planet's atmosphere, a complex and delicate task. Although the James Webb Telescope excels at characterizing planetary atmospheres, it was primarily designed for other purposes. It specializes in measuring variations in water vapor, carbon dioxide, and methane concentrations. While its ability to detect free oxygen, an important sign of life, is limited, the telescope can search for other vital atmospheric components like ozone, which indicates a healthy atmosphere. As scientists continue to analyze the data from the James Webb Telescope, the search for distant worlds and potential life goes on. This exploration brings humanity ever closer to answering one of our most profound questions. Are we alone in the universe? It's important to remember that the James Webb Telescope can observe only a limited number of exoplanets closest to Earth. For more detailed atmospheric studies, astronomers will rely on powerful ground-based observatories like the Extremely Large Telescope, ELT, scheduled to begin operations in 2028. The ELT will provide a deeper look into the atmospheric structures of distant exoplanets, delivering clearer and more detailed data on their potential to harbor life. Scientists eagerly anticipate the launch and operation of future space telescopes and advanced ground observatories. They plan to develop technologies that reduce starlight interference to better observe the planets orbiting those stars. Much like using your hand to block the sun's glare and see more clearly. By dimming the overwhelming brightness of stars, these telescopes will study the faint light reflected by exoplanets more effectively, improving our ability to analyze their atmospheres and assess their habitability. However, this task remains highly challenging. Stars are incredibly bright, often outshining their planets by many orders of magnitude, which makes it extremely difficult to detect the dim light planets reflect, light essential for studying their characteristics. To address this challenge, scientists are developing several innovative techniques. One such method involves coronagraphs, devices placed inside telescopes designed to block out starlight while allowing light from planets to pass through. By carefully shaping light waves, coronagraphs can significantly reduce the star's glare, making the faint light from exoplanets easier to detect. Another promising technology is the starshade, a giant flower-shaped spacecraft that flies in formation with a telescope. Positioned tens of thousands of kilometers away from the telescope, the starshade blocks starlight before it even enters the telescope's instruments, allowing only the exoplanet's light to reach them. This technique could be especially effective in observing planets within their star's habitable zones, where liquid water, and potentially life, might exist. These technologies, however, require extraordinary precision. For instance, the starshade's alignment must be accurate to fractions of a millimeter over vast distances. Additionally, future space missions must overcome limitations such as miniaturization, energy efficiency, and the harsh conditions of space. Despite these hurdles, the potential rewards are immense. Successfully observing and analyzing exoplanet atmospheres could lead to the discovery of biosignatures, chemical indicators of life. Molecules like oxygen, methane, or water vapor in specific ratios could hint at biological processes, suggesting life beyond Earth. Researchers are also exploring ways to directly image distant worlds in greater detail. Future telescopes might be equipped with advanced adaptive optics, which compensate for distortions caused by Earth's atmosphere or telescope movement, producing sharper images. When combined with starlight blocking technologies, these advancements could enable scientists to not only detect exoplanets but also map their surfaces and study their climates. The development of next-generation space telescopes represents a significant leap forward in humanity's quest to answer the timeless question: are we alone in the universe? By enhancing our ability to observe distant planets, we move ever closer to uncovering whether life exists beyond Earth, potentially revolutionizing our understanding of our place in the cosmos. Let me know what you think in the comments below. If you enjoyed the video, don't forget to like and subscribe. I'll see you in the next one.